Okay, so this is the third test that we're going to cover today. The first question is given provided the graph of f of x, answer the following questions. So here is f of x, this is the graph, and the first question is to evaluate this interval right here. What do we know about the definite interval? It gives us the net area under the graph. So I have to look at the graph of f of x from -9 to 3. So the area trapped under the graph is this area from -9 to -3, except that the definite integral is the net area, right? So that means that I have to evaluate this area right here, let's call it A1, and area A2. But we're going to say negative A1 plus A2 because the area A1 is beneath the x-axis. And then it's the area of two triangles, this triangle right here, which has, base 3 and height 3, right? 3 units base and 3 units height, and minus in front, plus the area of the same triangle here, 1/2 times 3 times 3, and that simply is equal to 0. For part B, it is the definite integral from -3 to 6, so we do the same thing from -3 all the way to 6, so it's going to be this area right here. So by this similar process, if I call this A1 and this area here A2, this is going to be equal to positive A1 because the graph is above the x-axis, minus A2. Why minus A2? Because this part of the graph is below the x-axis. How to calculate these? Well, I can see that this is a quarter of a circle, so 1/4 pi r squared minus 1/2 pi r squared. That's my area 2, and in both cases the radius is 3, right? So that's going to be equal to 9 pi over 4 minus 9 pi over 2, and that's simply negative 9 pi over 4. What we said in class, what would be the case if I have a question as the following one. Let's say evaluate the definite integral from -9 to -3 of absolute value of f of x dx. What does that mean? The absolute value, what does it do to the graph of the function? Just flips the portion of the function that is below the x-axis above the x-axis. So from -9 to 3, the graph is right here. So that means the absolute value is going to look like this, right? An absolute value of the function always, the graph is going to be positive. So basically I have the area of these two triangles added together. That's going to be 2 times twice the area, right? Twice this area, which is equal to 2 times 1/2 times base times height. So that's, these two cancel out. So that's simply equal to 9 because the base and the height is 3 units. Okay, moving on to the next question. It says that here you have to just circle the correct answer, and what is being asked. So here I have to just compare integrals. So this is the net area from 0 to 6. From 0 to 6, this is the graph. Obviously, it's a negative value, right? Compare it to this one right here. The definite integral from 0 to 8, that definite integral gives me this area right here. Okay, but what do we know? We know that both of these are going to be negative areas, right? So that means that this part here is greater. This is the correct answer, because in absolute value there is a less area. In absolute value there is a less area from 0 to 6, right? You can also calculate this if you want, but that's not the point here. It's not the point to actually check how much is the area from 0 to 6, although it has been calculated here. And then to negative 9 pi over 2, if from that one you subtract this area, then obviously negative 9 pi over 2 is going to be greater than negative 9 pi over 2 minus 1/2 2 times 4. So this is the correct answer. And in the last part, what do we have to compare? A definite integral to the second derivative. This is a slightly awkward question, but just checks whether you understand what's going on. The first is the integral from 0 to 1. The integral from 0 to 1, the definite integral from 0 to 1 is this part here with this area with negative sign in front of it. So we can see that that part is simply negative. The integral from 0 to 1 f of x dx is negative. On the other hand, what do we know about the second derivative? The second derivative gives us the concavity of the function, and at 1 right here, right, the function is concave up, which means the second derivative evaluated at 1 is greater than 0, which means f double prime at 1 is greater than the definite integral from 0 to 1 f of x dx. Moving on to the next problem, to the next part. Here all we have to do is evaluate these integrals. So I can set this up as definite integral of 7 times x to power 1/3 minus 7 times 1 over x plus 5 over x plus 1 over square root of 1 minus x squared dx. And these are just basic antiderivatives. So 7 times x to power 1/3 plus 1 over 1/3 plus 1 minus 7 times ln of absolute value of x plus 5 over x over ln of 5 plus arc sine of x. And then this is indefinite integral, so don't forget the constant of integration. Of course, make this slightly nicer. This is 21 over 4 times x to power 4 over 3 minus 7 times ln of absolute value of x plus 5 to the power of x over ln of 5 plus arc sine of x plus c. Moving on. In this question here, as we have done many times in our class, I'm going to separate this into 3 different fractions and then try to simplify this expression. So I have tangent squared x over sine squared x plus sine squared x over sine squared x plus 2 over sine squared x dx. Okay. So this is going to cancel right away. So I just have plus 1 plus 2 times 1 over sine is cosecant, so 1 over sine squared is cosecant squared. And the last part to answer is how much is this part right here. So tangent x over sine x is equal to sine x over cosine x over sine of x. These two cancel, so I'm left with 1 over cosine of x, which is nothing else but secant of x. And now on top of that, if I square this whole thing right here, squared, I just get secant squared. So that's how this fraction simplifies, secant squared of x. And now the integral of secant squared is tangent of x plus x minus cotangent of x plus c. Next are definite integrals. So the story here is that you have to find the antiderivative and then evaluate the difference of the antiderivative, evaluated the endpoints of this integral. Integral of sine is negative cosine of x. 1 over cosine of x is secant squared, and the integral of secant squared is tangent, so plus tangent of x from 0 to pi over 3. So first I plug pi over 3 for each x right here. Negative cosine of pi over 3 plus tangent of pi over 3 minus, and now I plug 0 for each x. Don't forget here to open the parentheses, minus cosine of 0 plus tangent of 0. So the angle pi over 3 is right here, and the coordinates of these points are 1/2 and square root of 3 over 2. So that gives me that the cosine of pi over 3 is 1/2 plus tangent of pi over 3 is sine over cosine, so that's simply square root of 3 minus cosine of 0 is 1, so minus 1 plus tangent of 0 is 0. So I get negative 1/2 plus square root of 3 plus 1, which is 1/2 plus square root of 3. And the second part is very similar. If you want, you can rewrite this as x to the power negative 1/2 plus 2 times x to the power negative 2 dx, evaluated from 1 to 4. Sorry, 1, not negative 1. The antiderivative is x to the power 1/2 over 1/2 plus 2 times x to the power negative 1 over negative 1, evaluated from 1 to 4. Before I plug in the limits of integration, I'm just gonna rewrite this expression to be slightly nicer. Minus 2 times 2 over x, let's say, evaluated from 1 to 4, and then I just plug these limits right here. So 2 times square root of 4 minus 2 over 4 minus, again, I'm pointing the fact that it's very important to open the parentheses here. 2 times square root of 1 minus 2 over 1. Square root of 4 is 2, 2 times 2 is 4, minus 1/2 minus 2 plus 2, or you can just cancel these two right away here. So I get 0. And the answer is 7 over 2. So this is an integral that asks definite integral of the absolute value. So here is going to be very helpful just to sketch the function absolute value of x minus 3. If somebody is wondering what happens to the 2 is a constant, so it can be factored outside of the integral right away, and then you have just the definite integral of absolute value of x minus 3 dx. This function looks like this, and the vertex is at 3, so 1, 2, 3, 4, 5, and I have to find the definite integral from -2 to 5, which, interpreting it as areas, I have the area of these two triangles right here. So that's going to be 2 times the area of the first triangle, 1/2 times 1, 2, 3, 4, 5 units for the base times 5 units for the height. So this here is 5. How do I know that? Well, just plug -2. -2 minus 3 is -5, in absolute value is 5. Plus the area of the smaller triangle, 1/2 times 2 times 2. So that's 2 times 25 over 2 plus 4 over 2, which is 2 times 29 over 2, which is 29. In the next problem, I have to do with this integral. Okay, so integral from 0 to square root of 3, 2x over, the only thing that I can do here is factor x, and I have x squared plus 1 dx. So I can cancel this x, and I can factor out the 2 outside of the integral, 0 to square root of 3, 1 over x squared plus 1 dx. The antiderivative is arctangent of x evaluated from 0 to square root of 3, so 2 times arctangent of square root of 3 minus arctangent of 0, and that's equal to pi over 3, 2 times pi over 3 minus 0, which is 2 pi over 3. Okay, so this problem here, I have told you in class that the problem is not going to be of this type, but rather something like the following function. So let's say g of x is equal to integral from x to 2 t times sine of t dt. Okay, so let's deal with this. And the first question is going to be how much is g of 2? So part A, g of 2 is equal to the definite integral from 2 to 2, t times sine of t dt, but from properties of definite integrals, we know that this is just 0. Part B, g prime of x is equal to the derivative of the integral from x to 2t times sine of t dt prime. Obviously, all we have to do is use the fundamental theorem of calculus. In order to do so, I need to adjust this integral. How am I going to do that? By flipping the order of integration. So from 2 to x, that comes with the price. I have to multiply the integral by -2 t times sine of t dt, and then find the derivative of that expression. A constant right here times the function, and then finding the derivative, the constant can come outside, times the derivative of the integral from 2 to x, t times sine t dt prime, and by the fundamental theorem of calculus, the derivative of the integral is just the function itself, so x times sine of x. As simple as that. And the last question, because the problem here, the optimization was done in class, so the last question that I'm going to do in this video is evaluating this integral as the definition of the integral, using the definition of the integral as a limit of Riemann sum. So as you can see, here is spelled out what you have to do. So the integral from 0 to 2, 2x squared plus 4 dx is equal to the limit, as n goes to infinity of the Riemann sum I goes from 1 to n of what? F of xi delta x. And now let's just figure out what delta x and f of xi is. Delta x is b minus a over n, so that's 2 minus 0 over n, which is 2 over n. Xi is a plus I delta x, which comes down to 2i over n, and f of xi is simply from the function here, 2xi squared plus 4, but now I have the expression of xi, so that's 2 times 2i over n squared plus 4, so 2 times 4i squared over n squared plus 4, which is 8i squared over n squared plus 4. So I'm going to plug this expression for my xi right here, and then I'm going to plug delta x right here, and I'm going to evaluate that limit of the Riemann sum. So limit as n goes to infinity of the Riemann sum of 8i squared over n squared plus 4 times 2 over n is equal to the limit as n goes to infinity of the Riemann sum of 16i squared over n cubed plus 8 over n. I'm going to split this into two Riemann sum, limit as n goes to infinity of the Riemann sum of 16i squared over n cubed plus the Riemann sum of 8n. N goes to infinity. So from here I can factor everything that doesn't depend on I in front of the Riemann sum. So that's 16 over n cubed Riemann sum of I squared plus Riemann sum of a constant as I goes from 1 to n is simply the constant 8 over n times n. So that part is easy. The formula for the Riemann sum of the first n squares is n times n plus 1 times 2n plus 1 over 6 plus here n and n cancels, leaving us just with 8. And now here, we've talked about this in class quite a lot, how to deal with this type of limits. So it's 16 times n, from the first parenthesis just factor n, so that's n times 1 plus 1 over n. From the second parenthesis again just factor n, leaving us with 2 plus 1 over n over 6n cubed. And here I've realized that I made a mistake. I didn't copy x cubed, but I copied wrongly x squared. This is n to the power 3 plus 8. Now we have to cancel. N times n is n cubed. Cancels out with the denominator. As you send n to infinity, 1 over n goes to 0. In this factor, 1 over n goes to 0. And we have 16 times 2 over 6 plus 8. This and this cancels, 3. So I have 16 over 3 plus 8, or that's 16 plus 24 over 8, over 3. And that's equal to, I guess, 40 over 3. You can always check if this answer is correct just by calculating this integral right here from 0 to 2 by evaluating the antiderivative. So that's 2x cubed over 3 plus 4x evaluated from 0 to 2. That's equal to 2 times 8 over 3 plus 16, which is 16 over 3, plus 8, here my bad. plus 8, which is exactly what we got right here. So our answer